We are Team Bugsoft, and for the past 5 weeks we've been working on a JavaScript browser game, Bugcrack, for the PPD assignment. I'm Jack, and I'm a developer/project manager.
I am Luke, and I am the lead programmer for the group.
I'm Dom, and I'm the main graphic and sound asset designer.
I am Ben, and I'm a developer and assistant sound designer.
Feel free to try the game out yourself. Enter the link or scan the QR code. Bugcrack is a tower defense based game in which the player is put into the shoes of a programmer who's then presented with the challenge of protecting their hardware from bugs.
The player is required to place turrets along the outside of the main data bus. Every turret you place costs energy, which you can gain from exterminating bugs. The main goal of the game is to defend from 10 progressively stronger waves of bugs and protect the CPU at the end of the bus.
After surviving a round, the player is rewarded with some energy that they can spend on better turrets or upgrades which include better range and dealing higher damage. Unwanted turrets can also be sold for a fraction of their initial price.
If a bug manages to get past your defences, the temperature of the CPU will increase up to 100 degrees and cause a system failure, at which point the player has lost the game and potentially their valuable machine.
If the player survives all the bug waves, they unlock the next level, which contains a high grade motherboard, more expensive CPU and therefore more challenging waves of bugs.
Completing all of the 4 levels unlocks the Endless mode, where no matter how skilled you are, you will eventually lose, as the CPU is on the verge of melting. The player that survives the longest will be put to the top of the leaderboard and get their bragging rights, until somebody better appears and beats their score by surviving longer.
In case you're in the mood of just enjoying the game without any worries, feel free to use the secret cheat menu to enhance your performance. In this section, we'll talk about the design and architecture decisions that had to be made while working on this project. For the aiming of the turrets and bug movement, initially I followed a tutorial, which is referenced at the end of this presentation, and got a basic setup for building the rest of the game. A lot of this code had to be rewritten to allow for further development, however, the aiming of the turrets still stayed the same. All the in-game objects, such as turrets, bugs and missiles, inherit from a base entity, which inherits from a phaser game object. Each entity then had its own base entity, which was inherited by the different types of that class. All images that are intended to be buttons use a button class. This allowed us to reuse code and add effects to buttons, such as hovers, easily.
Our rounds were originally created using separate functions and the levels were separate scenes, but this got messy quickly, especially when we wanted to update anything to do with the rounds. So once we were short on all the data that was required to change on a per round basis, we consolidated all that into a JSON file and just used that along with the generic round function. Bugcrack also has a leaderboard for Endless mode that stores players' high score, level and name that they've entered. This is accomplished by hosting an API made with Express on Luke's server, and the API then uses MongoDB to save and get the high scores, and lastly, Nginx is used to route the assets and do basic caching. A secret cheat menu has also been implemented. It is styled in Bootstrap and its contents are written in HTML, which is then accessed by JavaScript. It is not in the HTML header as to defer it from loading, because as we have found out, it resulted in a faster initial game load. Bug animation was a 2-part problem for us, because once I had the bug animation sprites done, we had to implement those into Phaser, which took a little bit of time, but the sprite sheets would eventually work.
With the sprite sheets implemented, the bug would only be animated while moving in one direction, left or right, and would not rotate depending on the path. To counteract that, some logic had to be implemented. While the bug's Y position is constant, animate it as normal. However, once a change in the Y is detected, the sprite sheet is rotated 90 degrees clockwise or anti-clockwise, depending if the Y increases or decreases. The same goes for the X dimension.
We decided to have a loading screen at the start of the game to load all the assets initially rather than as required. This makes it much faster to switch between scenes, but does require the loading screen at the start and might not be suitable for users on data plans. The path for each level was originally drawn using the graphics class in Phaser, with a line and a follower object. However, this made it difficult to get the bugs to spawn at different starting points, which was eventually one of the major issues due to higher levels with multiple bug entry points. We fixed this by generating the path from a 2D array stored in the JSON file and used a pathfinding algorithm to make the bugs decide where to go and randomly select one of the possible starting points.
We used the same 2D array to map out where each tile was in game, and converted it to a grid based on screen space with a given tile width and height. This grid is then used to place turrets on and detect if you can place a turret there depending on the value in the 2D array. Once a turret is placed, it changes that cell's value in the array to signify it is occupied. When it is sold, it is set back to vacant. The user interface, menus, game objects and game logic sections were created in different files and folders due to the complexity of the game. This allowed us to easily make changes down the line without everything being dependent on other parts of the code.
Within the first week, we got together several times and came up with a list of possible ideas for the project, and we decided on a tower defense type game fairly quickly as it seemed like it would be achievable in the given time frame. After looking into several frameworks for browser-based games, we decided that Phaser 3 had all the features and functionality we may need to implement our idea fully. A few days after deciding the game concept, we got to work making the foundation assets as well as setting up our development environment. Getting this sorted quickly meant that we could each go off and work on our own sections within the project.
We used Trello and Discord to communicate and keep track of our tasks. Luke set up our Discord server to receive notifications from GitHub, so our team was always in the know. Our development environment consisted of using Gitkraken for source control and VSC with a live share extension at times to collaborate on the same document. Using Gitkraken for this project was an essential decision that we made early on that allowed for easy collaboration and kept backups of the project. One of the things that we did quite well as a team was to manage our time effectively. This was partly down to the use of Trello to keep track of everyone's progress and complete work accordingly.
Each week we set goals, which most of the time were exceeded due to the enthusiasm from the team about the project. This was a result of regular communication between team members via Discord, which allowed for real-time feedback regarding work. Assigning each member a role went well, as each one of us could work on something they have experience with. For example, Dom, being the main graphical designer, meant that the style was consistent and the workflow was smooth.
One poor design decision that we made was doing the levels as a single background image. If we'd have built the levels using a level creator in a tile-based format, we could have created more levels at a faster speed, but we got slowed down slightly by having to create a new background image for each level. Although it seemed at the start that using an image would be faster, in hindsight I think it would have been worth spending the extra time at the start to design the tiles and use these as the basis for all the levels. Initially we thought it would be nice to include screen transition effects such as sliding while going from scene to scene in the main menu. However, it was later decided that the transitions would cause a ton of hassle and conflicts while switching between the scenes. Therefore, we stuck to the initial static scene changes we already had. However, given more time, we would definitely attempt to implement this feature.
Although we provided support for mobile devices, we had a problem in that the top bar of the browser, in landscape mode, forced the canvas to shrink. This is something that we could overcome by making the game into a progressive web app. However, we couldn't implement this feature due to the risk of not completing it in time. Another thing that we wanted to do was to get turrets firing in different ways. However, we were unable to complete this due to time constraints.
Additional features that could be added to the game in the future would include custom background music for every level, more different kinds of turrets and bugs, smoother animations for both. Unique events for each level, such as special power-ups tailored to that specific level, could also be implemented to enhance the gameplay. And not forgetting paid content to pay off our debt.